Hello everyone, welcome to our channel. Let's learn together. So today we are going to talk about the Gauss forward and backward interpolation formulas. First I will be talking about Gauss forward interpolation formula, and this can be obtained by following some of these steps. Let's consider that we have the data of x and y values. Okay. First what we have to do? We have to choose the origin perfectly from the given values of x. Suppose these are the given values of x and we have to choose the origin properly. So for now I have chosen x0 as our origin and I have named it as x0. Now we have to write the values of x above the origin as negatives and below, this is the origin, right? And below the origin as positives. Okay. Now let's complete this table. And one more thing, for the simplicity of understanding the Gauss forward and backward formulas, we use the forward notations in the central difference table. So now we are going to write the central difference table. I have already explained what is central difference table in the previous videos. Do check that. Okay. So let's complete the table. That is we have to do the central difference table now. X and y values are given. Okay. Now start doing. That is y minus 2 minus y minus 3, right? Which is delta y minus 3. And you just have to subtract. I think you know the central difference table and I am just writing it. Okay. Del y minus 1 and subtraction of y1 minus y2, which is del y0. y2 minus y1 is del y1 and y3 minus y2 is del y2. Okay. I mean delta y2, sorry. And again subtract this delta y minus 2 minus delta y minus 3, which will be equal to del square y minus 3. Similarly here, del square y minus 2, del square y minus 1, del square y0 and del square y1. Okay. And same here. What you have to subtract these both. And you will be getting del cube y minus 3, del cube y minus 2, del cube y minus 1 and del cube y0. Okay. Again subtract here del power 4 y minus 3, del power 4 y minus 2 and del power 4 y minus 1. Again same, del power 5 y minus 3, del power 5 y minus 2 and again del power 6 y minus 3. Okay, we have prepared the table now. Now we have to identify the Gauss forward and backward ones, right? So for the Gauss forward interpolation, what are the values we have to consider in this central difference table? Now we are starting with Gauss forward, right? From the origin you have to go backward, like in this way. This is the forward one. Like this you have to go. Okay. And here again. And these are the values we will be using for the Gauss forward interpolation formula. So now here also we have to consider that the values of x are equally spaced and h is the difference between them. Okay. The h will be the difference between them so that they are equally spaced. And also the p value is x minus x0 by h, but the p value lies between 0 and 1 for all the Gauss forward formula. Only for Gauss forward formula. Okay. So this is our Gauss forward interpolation formula, which is y is equals to y0 plus p delta y0. You have to consider these values. Okay. I have shown here in the table, right? y0 plus p into delta y0 plus p into p minus 1 into delta square y minus 1 by 2 factorial plus p plus 1 into p minus 1 into delta cube y minus 1 by 3 factorial and so on. Okay. We'll learn more about the Gauss interpolation forward interpolation formula with some examples. Now coming to the Gauss backward interpolation formula, what are the values we have to consider? Let's see, okay? These lines are for the Gauss forward interpolation formula. I haven't erased it yet, but now we'll check for Gauss backward, okay? For backward from here, so these dotted lines represent the backward one. So from here you have to go, that is for del square y1, and from here like this. So what these represent, that you have to use these values in the Gauss backward interpolation formula. So what are the conditions here? Same as the Gauss forward one only. So the values of x should be equally spaced, and here p value is x minus x naught by h, and the p value lies between -1 to 0. Okay, and the dotted lines in the central difference table indicates the values that are to be considered. Okay, now we'll write the formula of Gauss backward interpolation. This is the formula of the Gauss backward interpolation formula, that is y0 plus p into, I have told you, you have to consider these values, right? P into delta y minus 1 plus p plus 1 into p into del square y minus 1 plus p plus 1 into p minus 1 into del cube y minus 2, and so on. So this is all about the Gauss forward and backward interpolation formulas. So let's talk about Gauss forward interpolation formula with an example. So here is the data of x and y values. Now we have to find the value of y at x equals to 3.3. So here we don't have the value of y at x equals to 3.3. So we have to use the Gauss forward interpolation formula. So consider the origin. So origin will be x naught. So x naught here is 3. So this is our origin now. Okay. Now as I have said, we have to write the central difference table, right? So let's write the central difference table first. Now what you have to do? Subtract these both values, which is 15.10 minus 15.30 will be minus 0.2, 15.0 minus 15.10 will minus 0.1, and these two is minus 0.5, and for this it will be also minus 0.5. okay, now again minus 0.1 minus of minus 0.1 will be plus 0.1, and this will be minus 0.4, minus 0.5 minus of minus 0.5 will be minus 0.5 plus 0.5, which is 0. Again subtract minus 0.4 minus 0.1 minus 0.5, and this value will be 0.4. 0.4 plus 0.5 will be 0.9. So now we have written the central difference table. Now you have to find the values for using it in the Gauss forward interpolation formula, right? So first from the origin, let's go. You think that this is Gauss forward interpolation formula. Okay, remember that. From here you have to consider these values, 0.4 and again 0.4 and this one. Okay, I think this is visible, right? Yeah. Now calculate the p value. P value is x minus x naught by h, which is x is nothing but 3.3, right? 3.3 minus x naught is 3 divided by h. H is the difference between all these values, right? And they are equally spaced. That is h equals to 1, the difference between these values, that is x values. So h is 1, which will be 0.3. P is 0.3, and earlier I told you that the p value should lie between 0 to 1 for the Gauss forward interpolation formula. So it lies between 0 to 1. Now according to the Gauss forward interpolation formula, that is y is equals to f of x, which is equal to what? Y naught. What is y naught here first? This is y naught, that is 15.00. This is y naught. I have told you, right, what you have to take from the origin. Above the values of origin, you have to take the negative values. These are y minus 1 and y minus 2. And below the origin, you have to take the positive values, that is y1 and this is y2. Similarly, I think I have explained in the recently I have explained. So now this is our Gauss forward interpolation formula, and now we will substitute the values, that is y is equals to y naught. What is y naught? Y naught is this one, that is 15, and plus, you know, right, from the origin we have to take the upper one as the negative values and the down one as the positive values. I have explained just now, right? Now P is 0.3 into delta y naught. Delta y naught is minus 0.5. So here I have highlighted, right, these are the values you have to follow, okay, like this. I mean, these are the values you have to use in this formula. Into 0.5 plus P into P minus 1, that is 0.3 into 0.3 minus 1 into del square y minus 1, that is minus 0.4 divided by, okay, I think I have missed the 2 factorial here, okay, divided by 2 factorial plus P plus 1. P plus 1 is 0.3 plus 1 is 1.3 into P. P is 0.3 into P minus 1. That is what? 0.3 minus 1 divided by 3 factorial into del cube y minus 1. That is 0.4 plus P plus 1. P plus 1 is 1.3 into P is 0.3 into P minus 1 0.3 minus 1 into P minus 2 0.3 minus 2 divided by 4 factor into del power 4 y minus 2 is 0.9. Now calculate the whole value, okay. Calculating this whole value, you will be getting 14.863562.5. So this is the value of y at x equals to 3.3. Now let's see the example of Gauss backward interpolation formula. So use the Gauss backward interpolation formula for the population of team for the year 1974. Here this is the year and this is the population. For the year 1974, we have to find the population, that is the y value. Here, so let's find the origin. Using the central difference table, I think the 1974 lies in between the 1969 and 1979, right? So this will be our origin, 1969. That is the mid value, okay? Now complete the central difference table. Delta y, delta square y, delta cube y. Okay. Now subtract 15 minus 12 is 3. 20 minus 15, 5. 27 minus 20 is 7. 39 minus 27 is 12. 52 minus 39 is 13. Again subtract 5 minus 3 is 2. 7 minus 5, 2. 12 minus 7 is 5 and 13 minus 12 is 1. Again subtract 2 minus 2, 0. 5 minus 2, 3. 1 minus 5 minus 4. 3 minus 0 is 3. Minus 4 minus 3 is minus 7. Minus 7 minus 3 is minus 10. Okay. Now identify the Gauss backward interpolation values from the origin. You have to go in this way, right? Let's use the dotted values from here, like zig up and down, okay, so that it will be easy for you. So what are the values you will be using in the formula? 27, 7, 5, 3, minus 7 and minus 10. Okay. Now what you have to calculate? The p value, which is x minus x naught by h. That is, x value is 1974. X naught value is 1969. H is the difference between these values, right? As they are equally difference between the x values which are equally spaced. That is 1949 minus 1939 is 10. H value will be 10 and it is equals to 0.5. p value is 0.5. Okay. So now using the formula, substitute all the values, that is y is equals to y naught. What is y naught? So this is the y, right? This will be our y naught and this will be our y minus 1, y minus 2 and y minus 3. I have explained in the table previously, right? What are the values you have to take? So y naught will be 27 plus p into p is 0.5 into del y minus 1. Del y minus 1 means 7. Delta, sorry, okay. Into 7 plus p plus 1. P plus 1 is 0.5 plus 1 is 1.5. 1.5 into p is 0.5 divided by 2 factorial into delta square y minus 1, which is 5 into 5 plus p plus 1. P plus 1 is nothing but 0.5 plus 1, 1.5 into p, 0.5, p minus 1, 0.5 minus 1 divided by 3 factorial into delta cube y minus 2 is 3, right? Into 3 plus p plus 2. P plus 2 is nothing but 0.5 plus 2 into p plus 1 is 0.5 plus 1 into p. Into p is nothing but 0.5 into p minus 1, 0.5 minus 1 by 4 factorial into delta power 4. Delta power 4 is minus 7 plus again p plus 2, 0.5 plus 2 into 0.5 plus 1. Just use this formula, okay? P is 0.5 into 0.5 minus 2 divided by 5 factorial into delta power 5 into y minus 3, which is minus 10. So calculate this whole value, you will get y as 32.167. So the value of y at x equals to 1974, that is the population at the year 1974 is 32.167. This is all about the Gauss forward and backward interpolation formulas. Thanks for watching. Do like, share and subscribe for more videos, and do check the playlist of mathematical transformation techniques course for all the videos I have uploaded there. Thank you. Bye.